Hello, welcome to our video about right triangles. First, let's talk about the pieces that make a right triangle a right triangle. Most of us at this level understand that a right triangle uses the square to represent that angle right there is 90 degrees. And that's what makes a triangle right. And let's go ahead and talk specifically about what the hypotenuse is and also the legs. The hypotenuse is the side that's opposite the right angle. So if I start at my right angle over here and I go opposite of that, just pointing in that direction, this slanted side is called the hypotenuse. And the legs will be the two sides that form the right angle, and they're not always congruent. And I think this picture kind of shows that. Like these two sides here are going to be called the legs because they're the two sides that are creating the 90 degrees. And I guess really I should just say leg and not legs. So let me erase that over there. So there are two legs and one hypotenuse for each right triangle. And again, just keep in mind that the hypotenuse is opposite of those 90 degrees and the legs are the two sides that create the 90 degrees. So actually what we're going to be focusing on with right triangles is pretty much what we just got done doing with the other triangles, all the other triangles with the congruence statements, the side, angle, angle, and angle, side. And we did very briefly in the last practice was introduced to hypotenuse leg, and that actually is going to show up here also. But the thing about it is that these theorems that we're about to talk about of congruence of right triangles are just special cases. So let me add in here, special cases of previous theorems, which technically means you're not going to learn any new skill here. It's just applying those side, angle, and angle, side, specifically to right triangles. And we'll take a look at that as we go through these examples. Okay, so before talking about specifically right triangles, if we were to take a look at these two triangles here, I see a set of sides are congruent, I see they have congruent angles, and then they have another side that is congruent. So based on our previous knowledge, these two triangles would be congruent by side, angle, side. Now, if we take a specific look at the fact that that angle happens to be a right angle, making it a right triangle, we can actually use what is called the LL theorem, which stands for leg theorem. So this is going to be the LL theorem, and it's going to be based off of the fact that if the legs of a right triangle are congruent to the legs of another right triangle, then the triangles are congruent. Again, it's just a special case of that side, angle, side. So you can know that, and I want you to make that connection, but it's technically called the leg theorem with the right triangles. In this next set of triangles here, again, we have the right triangle, but if we look, in addition to that right triangle, we also have another pair of congruent angles, and then we have a pair of congruent sides. So based on our previous theorems, this would be an angle, side, because the side is not the included side, it's the side that's on the outside. So angle, side, using the previous theorems. Applying it to right triangle specifically, this is called the HA theorem for the hypotenuse angle, which says if the hypotenuse of two right triangles are congruent and they also have one pair of congruent angles, then the triangles are congruent. So that's the hypotenuse angle theorem based off of the angle, side theorem. This next theorem is going to be based off of these triangles. So if we compare these triangles here, we've got an angle and then congruent sides and then another pair of angles that just happen to be those right angles. But in this case, the side is that included side. So the theorem that we're going to be basing this off is the angle, side, angle theorem. But again, because these are specifically right triangles, this is actually going to be called the LA theorem for leg angle theorem, which states that if two right triangles have one pair of congruent legs and one pair of congruent angles, then the triangles are congruent. So you really only need, once they're right triangles, you really only need two things to prove that they are congruent. A set of legs and another set of angles. Another set of angles, not the right angles. Please notice that with the last theorem as well as this one. Okay, last but certainly not least is actually the theorem that was included in the previous videos with the triangle congruence in that graphic organizer before, which is about the hypotenuse leg. And the hypotenuse leg theorem states that if the hypotenuse of two right triangles are congruent and they also have one pair of congruent legs, then the triangles are congruent. So this is the HL theorem. This is the hypotenuse leg theorem. And this is the only one that does not have one of the four previous triangle congruence statements, shortcuts to use, because there's none that says side, side, angle, or angle, side, side. So this is the only one that doesn't match up with one of those, but because it is a right triangle and it is specifically the hypotenuse and one of its legs, it is always going to be congruent. So we use the hypotenuse leg theorem. That's all that we need in order to say that these are congruent. All right, so here's just a slide summary of these four congruence theorems based on specifically for right triangles. And I think the thing to really focus on is that each of them only needs two parts in order to prove that the triangles are congruent, because these are already only specific to right triangles, so they already have that angle there. So this is specific to that. So in this first one on the top left, this is our hypotenuse leg. You can see that they're colored. If the hypotenuse and a pair of legs are congruent in two right triangles, then the two right triangles are congruent. If the hypotenuse and a pair of angles are congruent, then the right triangles are congruent. And just to focus here, actually I'll talk about this in both of these. The angles in this theorem, as well as this leg angle theorem down here, the leg angle theorem, needing a pair of legs and the pair of angles, those angles are not supposed to be the 90-degree angle, okay? These angles are not counting as the 90 degrees. That's going to be in addition to your right triangle, something to keep in mind there. And then the last one here in the bottom left, these are when the two legs are congruent. So if the legs are congruent, then you are good to go. You're just missing the hypotenuse, but technically from the two legs, you can say that the triangles are congruent. So therefore the hypotenuse really is also. So again, with the right triangles, you only need two sets of information to be congruent, because you already have that they're right triangles. So something to consider as we go through these practice problems. All right, so practice problems, we're going to write a congruent statement for each pair of triangles using either leg, leg, hypotenuse, angle, leg, angle, or hypotenuse, leg. And if we don't have any of those four things, then we will write not possible. All of these examples will be right triangles. So it looks like in this, I have a hypotenuse. I'm just gonna label it with an H. I have the hypotenuse and I have an angle, and they are matching angles and other corresponding angles. In other words, like it's not F, like this one's down here and this one's up here. Like these are marked congruent. They're on the bottom, so they are matching. So this is going to use the hypotenuse angle. And so my congruent statement will say triangle, I don't know, I'll just start with FED. So I'm starting with the FED. So that means I need to say is congruent to triangle RQP. RQP. You need to be going in that same order. And I will say by hypotenuse angle. And there's my congruent statement and actually my justification along with that. Continuing on here, still again, right triangles. So that's going to shorten my requirements. I only need two things to match. And in this case, I have the legs that are matching. So I have a leg, a leg, a leg, a leg. So, I mean, I'm using these letters for a reason, like to show you that they're matching that LL right there. So we're going to say that triangle, I'll start with the right angle here, EFD. D is congruent to triangle Q. Now if I start with the Q, I have to go to R because I went from E to F, which followed down that single tick mark side, so I have to do the same thing with the other triangle. So Q, R, P, and that's by leg, leg. All right, in this next example, again, we still have the right triangles, but this looks a little bit more complicated. I've got a couple different angles and the right triangle, and I do have one set of legs. They're not the hypotenuse because the hypotenuse is this slanted side here opposite of those right angles. And it looks like, based on what I have here, I've got a leg and a leg. So the question is, are those the same legs? Are they corresponding legs? So what I'm gonna try to do is use that. Hold on a second, let me ungroup that. So if I take, I want this thing. Sorry, let me delete this. All right, so I'm going to take this one. So this is the RQP down here, and if I rotate it around, and I'm just gonna make it smaller. I know that they're congruent, so they really should be the same length, but I want you to see how they fit up and how they correspond to each other. The D and the P both have the single angle mark. There's my congruent sides, there's my right triangles, and then the double congruent angle marks. So that's visually like what I'm trying to do to make sure that these are actually congruent, matching all of that stuff up. It just so happens that it's working by, let me see if I can make this the same size. Using the, let me recolor this. There's a leg, and then we've got quite an assortment of angles here. So the point is that we have a leg and an angle. So that's the theorem that we're going to use to prove that these two triangles are congruent. So I will say that triangle DEF is congruent to triangle PQR by leg angle. And again, pay attention to your order of your statements with your letters. I started with D, which is the single angle mark, then I went to the right triangle, or the right angle, so I had to start with P and go down to Q when I was writing the second part. Fourth problem here, it looks like I've got a hypotenuse, and it might, again, look a little confusing here, but that is the side that is opposite that right angle, so this is the hypotenuse. And then I have several angles here, so I'm just going to circle a pair of them, but there is the angle and the hypotenuse, which matches my hypotenuse angle. So I'm just going to write my congruent statement. Triangle PQR is congruent to triangle. So I started with the single angle marker, so I'm going to go D, then I went to the right angle. So triangle PQR is congruent to triangle DEF by hypotenuse angle. All right, number 5. It looks like we have our right triangles, but then this is a very blank example here. We've got only a leg. We have a pair of legs, and that's it. Because remember that the right angle does not count as an angle in the leg angle, or even in the hypotenuse angle theorem. So in this case, we're gonna say not possible because there's not enough information. There's not enough congruent information to say that these two triangles are congruent. Now we can't say that they're not, which is why we're not saying not congruent. We're simply just saying that it's not possible to write the congruent statement with the information that is provided, okay? Just one pair of legs isn't going to do it. And then I just wanted to include these last 3 examples. Also, you can take a look at them. I'm not going to talk through them, but if you pause the video now, I will put the answers up in just a second. So if you pause the video, try them on your own, and then you can check in just a second. Thanks for watching.